everyone, I'm Belle Reid and welcome back to another video. So today I'm going to talk about Pittsburgh Modular's new semi-modular synth called Taiga. Taiga is a semi-modular analog synth that borrows ideas from some of Pittsburgh Modular's prior modular designs, and it's heavily inspired from recent collaborative designs with Create Audio, namely the East Beast and the West Pest. If you're familiar with those synths, you'll notice that Taiga has a lot in common with them, but it's really its own thing, so it deserves exploration unto itself. In this video, we're going to take a look at what Taiga contains, and then I'm going to share a number of patch ideas from my recent explorations. The techniques I'm going to share here are oriented towards slightly more experimental textures and noise patches. In my exploration so far, I've found that Taiga really excels at complex, dense, and noisy sound worlds, so that's where most of my attention today is going to be focused. Thanks to Pittsburgh Modular for sending me one of these to check out. If you're interested in picking up a Taiga of your own, there are some affiliate links in the description of this video. And anything that you purchase using those links helps to support my channel, so thank you. Okay, with all that said, let's see what Taiga is all about. Taiga draws significantly from the work that Pittsburgh has previously done with Create Audio on the East Beast and West Pest. As their names might imply, the East Beast and West Pest are synths designed to explore the concepts of East Coast and West Coast synthesis. If you've been playing synths for a while, you've probably come across the terms East Coast and West Coast before. But if these terms are new to you, in a nutshell, East Coast synthesis generally follows design ideals pioneered by Bob Moog in the 1960s, which eventually became the de facto standard for how most synthesizers are designed. This approach to synthesis tends to use standard wave shapes, resonant filters, and is generally oriented toward use with keyboards, sequencers, and other fairly typical control methods. West Coast synthesis, on the other hand, takes inspiration from the work of Don Buchla. While East Coast synthesis has become relatively common in synthesizer design as a whole, Don Buchla's approaches to sound design and interaction have remained relatively obscure until recent years. So-called West Coast designs, inspired by his instruments, commonly use wavefolders, low-pass gates, complex random voltage generation, and experimental means of user interaction. There's a link in the description of this video to a resource where you can read more about East Coast and West Coast synthesis if you're interested. The core components inside Taiga reveal equal influence from both of these schools of thought. It has 3 oscillators, a resonant filter, and ADSR envelope generators, like you might find in an instrument like the Mini Moog. But at the same time, it has 3 wavefolders and a low-pass gate. Those are the types of things you would ordinarily only find in a Buchla-inspired synth. Taiga also has a number of other components, so let's take a quick tour of the panel. Generally speaking, the signal flow inside of Taiga is more or less identical to the signal flow you'd find in a Mini Moog or any standard mono synth. But you'll notice there's an enormous patch bay here along the bottom. It makes extensive use of normal connections in order to create this standard signal path, but it's fully modular by way of the patch bay. You can interrupt the signal flow at any point in order to create different signal routings. On the left side, there's a MIDI to CV converter. This section also includes arpeggiation and sequencing functionality. It also allows for paraphonic control of the synthesizer so that you can play chords with external MIDI control. Here there are 3 analog oscillators. Each one offers a number of different wave shape selections: sine, triangle, saw, square, and several combinations of each. Unlike most wavefolder designs, it works with any wave shape you select. Even saw and square waves sound great when folded. There are CV inputs for oscillator FM and the shape parameter, and we also have sync inputs for each oscillator as well. Next is a 5-channel mixer, including 1 channel that's tied to the preamp. These 4 inputs are normal to the 3 oscillators and a noise source. Here we have a preamp level and gain control, and a simple LFO with triangle and square outputs. Regrettably, there's no CV input for the LFO, but the oscillators can go into very low frequency territory if needed. Next, there's a filter, which is the Pittsburgh filter design found in the East Beast. It's a multi-mode resonant filter with high-pass, bandpass, and low-pass filter options, and several combinations of each. There are 2 CV inputs for the filter cutoff frequency. Moving along, there are 2 ADSR envelope generators, and like the LFO, these have no voltage controllable parameters. The next section is dynamics, which is Pittsburgh's unique take on the concept of a low-pass gate. So in addition to typical low-pass gate parameters, you get variable response, which controls the ring time, and variable resonance. There are CV inputs for both the gate level and the response. On the far right of the panel, there is a delay with voltage control of the time parameter. The patch bay contains a number of other utilities that don't have any front panel controls, including a noise source, sample and hold, and an auxiliary mixer splitter with 2 inputs and 2 outputs. Now, it's worth restating that all of the modules I just described are fully modular. The normal signal path makes it such that it's easy to set up traditional mono synth sounds, but because each submodule can be freely patched, you can do much more as well. Now that we've looked at everything that's inside Taiga, its relationship to other synthesizers of the past should be fairly clear. 3 oscillators running into a resonant filter is a standard signal architecture that's been around since the Moog systems of the 1960s. This means it's good at classic synth leads. And bass lines. And the inclusion of a MIDI to CV converter means that you can do everything from arpeggios to even paraphonic synth pads. And of course, the inclusion of more West Coast-oriented components means that it's also good for eccentric and experimental sound design. So while it can cover all of that ground, what I've been finding is that having this particular combination of features in a single instrument is leading me towards sounds that I wouldn't expect to hear on a classic Moog or Buchla record. So for the rest of this video, I want to unpack some of these more peculiar things that I have been discovering. of the things that immediately caught my attention about Taiga is that there are 3 independent wavefolders. The only synths I've ever used that have had wavefolders built in have had only one of them. So I was really excited to try different patch ideas that combine multiple wavefolders together in different ways. In the example we just heard, I was manually adjusting all 3 oscillators' wavefolders, but these all have CV inputs as well, which opens up a whole bunch of cool opportunities. I wanted to explore using one of the audio oscillators as a modulation source for another oscillator's wave shaper. So in this patch, I'm using the output from oscillator 3 to modulate the first wave shaper. So now if we change the pitch of oscillator 3, it's going to have a big impact on the wave shape of oscillator 1. And we can even modulate the shape parameter on oscillator 3 itself to get to more complex sounds. Or in other words, we can wavefold the wave that's modulating the wavefolder. All right, awesome. So let's take a look at this idea in a more fleshed out patch context. So in this patch, I have the first 2 oscillators very slightly detuned from one another, and I'm using the output from the 3rd oscillator to modulate the wave shape of both the first and second oscillators. Then I'm also using the 0 control, which is this touch sequencer, to send some additional modulation. The top row here is being sent into the pitch input on all 3 oscillators, and the pressure output from the 0 control is being used to modulate the wave shape of oscillator 3 and to open the low pass gate. So let's take a listen to this. One of my favorite modular synth techniques is self-patching and working with feedback to create complex textures and timbres. One idea I was really interested to explore on Taiga in particular is the idea of inserting nonlinearity into a control feedback loop. So in simpler terms, I wanted to try using an oscillator to frequency modulate itself. On most standard analog oscillators, this isn't terribly interesting. Usually as you increase the FM depth, it'll just end up changing in pitch and timbre slightly. But here, since we have a wave shaper per oscillator, it becomes possible to create much more complex behavior simply by varying the FM depth and the amount of wave shaping applied to the oscillator. So I'm going to start off by taking the output from oscillator 1 and running it into the FM input on oscillator 1. Now I'm going to add a little bit of pitch modulation from the zero control to oscillator 1. Cool, so this is pretty awesome, but I have 3 of these oscillators that I can do this with. So let's look at a couple of patch examples that use this technique on all of the oscillators simultaneously. In the previous examples, each oscillator was frequency modulating itself, but things get a lot weirder when you start to use the oscillators to frequency modulate each other instead. So for this example, I'm going to take the output from oscillator 3 and use that to frequency modulate oscillator 1. I'll use oscillator 1 to frequency modulate oscillator 2, and the output from oscillator 2 to frequency modulate oscillator 3. So these are all connected in a big feedback loop with one another. I'm going to expand this patch slightly by using the sine wave output from one of the oscillators to modulate the filter cutoff. Let's combine some of the ideas we've looked at so far and try applying this self-patching feedback technique to the wave shapers. So like before, we'll start by using just a single oscillator to modulate its own wave shape. So I'll patch from the output of oscillator 1 into the wave shape CV, also on oscillator 1. Of course, we can also use the oscillators to modulate each other's wave shape as well. Here's a particularly crazy example in which all of the oscillators are modulating each other's wave shapes in a big circular feedback loop. Oh, just a quick bonus tip. If you click the wave shape select button until all of the LEDs are illuminated, and then you enable MIDI on the oscillator, a new wave shape will be selected at random with each new incoming MIDI note. So we can go ahead and turn that on for all three of our oscillators and enable MIDI on these and see what that sounds like. You can also do the same thing with the filter, which is pretty cool. So I'm going to go ahead and turn on all of the LEDs here. So now with each new incoming note, it's going to choose a new filter setting at random. Taiga has a preamp with up to 30 times gain. This can be used to boost external instruments up to levels for use within the synthesizer, but that's also enough gain to provide some pretty gnarly distortion sounds within the system too. So in this patch here, I am running the mix into the preamp, and then I'm running out from the preamp into the filter. And I'm using the zero control for some pitch modulation and to trigger the envelope. I'm going to start with the gain turned all the way down and then gradually turn it up so you can hear the effect it has. And of course, we can use the preamp as a way of processing external signals as well. So I'm going to run the signal from my mic into the preamp here. And now there are some pretty obvious things we can do with this, like we can use Taiga to filter or to add a delay to the external sound. But the patch I want to share here is a little bit weirder. The idea behind this patch revolves around the fact that these oscillators can go really, really slow, well beyond the point at which they're effective as audio oscillators. Something I discovered is that if you set the oscillators to this very low frequency range and then modulate the wave shape, the net effect is something like a weird nonlinear distortion, almost like you're wavefolding the modulation signal itself. So I'm running my external mic input as before into the preamp. The output from the preamp is going into the CV input for the wave shape of oscillator 3. This is really cool, in my opinion, because there are so many different parameters that are going to have a big effect on the timbre. Changing the wave shape selection, the shape parameter, the shape mod depth, the preamp gain, all is going to have an effect on the resulting sound. So far, I've been doing this in a controlled setting wearing headphones, but this patch gets even crazier if the microphone that you're processing can hear the sound of Taiga itself. Adding that extra layer of acoustic feedback can really send things spiraling. So I'm going to take my headphones off and listen to things now through my studio monitors. You're going to notice a somewhat delay-like effect. This is just the result of the latency on my audio interface. That's not necessarily a bad thing. I think it sounds pretty cool, but just note that if you try this at home, you may get slightly different results. All right, so we've taken a look at a bunch of different ways to create what are, in my opinion, pretty crazy but awesome sounding patches. Of course, it's good to remember that Taiga is also great at creating all kinds of more standard synth sounds, as we touched on briefly at the beginning of this video. But in my explorations, I've personally been gravitating toward these more complex and gritty and noisy sounding patches. If you're interested in picking up a Taiga, there is an affiliate link below, and anything that you purchase using that link helps to support my channel so I can create more videos like this one. Also, I wanted to let you know that I've put together a free Introduction to Modular Synthesis mini course, which is called Your First Modular Synth Patch. As the name suggests, this course teaches you the fundamentals of modular synthesis and modular signal flow, and it walks you through how to build your first few patches completely from scratch. It's completely free to enroll, and you don't need any special gear or equipment to participate, just a computer running the free software VCV Rack. My goal for putting together this class is really just to help folks take their first steps into this world, because modular synthesis in general is a topic that I am personally so passionate about, and I just wanted to be able to share that with you. So I hope you find it helpful. There is a link to the class in the description of this video so that you can sign up and get started. Okay, and with all of that, that's it for today. As always, thank you so much for watching and for listening, and I'll see you next time.